Welcome to the NJIT website and math podcast. My name is Vanessa, and today I'll be covering solving equations by factoring. Okay, all equations by factoring generally deal with factoring polynomials. And even though the polynomials can increase and can be very complex depending on the number of terms that are in the equation, essentially they all have the same basic recipe. The recipe is you want to move all terms to the left side of the equation to set the equation equal to 0, do any possible factoring or factoring out or opposite of distribution and bringing terms into certain terms of quantities, and then that can be multiplied together. And then what you can do is, because they're multiplied together, you split them apart and then set each of them equal to 0 and solve them individually. So now I'm going to do two examples demonstrating this process. Let's start with one that's very basic. Okay, let's say if we had this problem. X to the fourth is equal to 9x squared. Alright, so first step is to put all the terms on the left side of the equation to set it equal to 0. So I'm going to move the 9x squared over by subtracting. So it'll be x to the fourth minus 9x squared equal to 0. Okay, the next step is to do any possible factoring that we can. In this case, we can factor out an x squared out of each term as such. And then on the inside we have x squared minus 9 equal to 0. Okay? Now you may think this is all we can do, but actually it's not, because the x squared minus 9 is a perfect binomial which can be split up because it's an a squared minus b squared binomial. So this actually can be broken up even further into x squared times x minus 3 times x plus 3 equal to 0. Right? So now it's in its most simple form, and we can't break it up anymore. So now we have three terms: x squared, x minus 3, and x plus 3. So what we're going to do is now we're going to turn them into three separate equations that are equal to 0 because they are multiplied. If they were added, we couldn't do this. So now we're going to have three equations. We're going to have x squared equal to 0, x minus 3 equal to 0, and x plus 3 equal to 0. And we're going to solve them each individually, which is pretty easy. So x squared equal to 0. Take the square root of both sides, which just simply gives us x equal to 0. X minus 3, add 3 to both sides, gives us x equal to 3. And then here on x plus 3, we need to subtract 3 from both sides, which just gives us x is equal to negative 3. And that's our answer. We have three answers. We have x equal to 0, x equal to 3, and x equal to minus 3. Pretty simple, right? Now we're going to do a problem that has more terms in it, but it's not really any harder. Just got to follow the same basic recipe. So let's try another one. Say we had x cubed minus 2x squared is equal to minus x plus 2. Okay, same first step. We need to get everything to the left side of the equation. So I'm going to add x and subtract 2. And this will cancel out on this side. And then you're going to add x and subtract 2. So our equation now is x cubed minus 2x squared plus x minus 2 equal to 0. So now all of our terms are on the left side of the equation, and we can move on to the next step. Now we don't have anything, we cannot factor x out of every term, so that's out. And it's a cubic, so we're going to have to think of something else to do. Generally, what's a good step to do is to split it up. We're just going to divide it right in half. So we're going to take the first two terms and bring them together, and then we're going to take the last two terms and bring those together and see if we can do any factoring that way. In the first set, we can factor out x squared, right? So we're going to factor out the x squared, which leaves us with x minus 2 here. And then we can't do anything with x minus 2. But, as you can see, we notice something that both sets now have an x minus 2 in it. In the first one, we have an x squared in the front. In the second one, even though we don't have anything, there's still an imaginary 1 in the front. So, what we can do is, now we can bring those together by grouping. So the first set is going to be x squared plus 1, which is basically the leftovers of here and here. And then the other set is simply going to be x minus 2. And still equal to 0. And then finally, the last step, which is the same as before, is because the two terms are multiplied, we can separate them and solve for each individually. So let's do that. So we're going to have x squared plus 1 equal to 0, and x minus 2 equal to 0. So for the first one, we need to subtract 1, which gives us x squared equal to negative 1. Now, if you are allowed to deal with imaginary numbers by taking the square root on both sides, normally you won't be able to take the square root of a negative number because technically it's undefined or imaginary. But just in case, if you're allowed to deal with imaginary numbers, it'll be on this side. When you're taking the square root, it's always plus or minus. And then it's going to be square root of a negative 1 is I. And then on the right side here, we just simply add 2, and then x is equal to 2. So here technically we have three answers. X is equal to 2, and x is equal to plus or minus I. And if for any intents and purposes, if your professor says don't take into account imaginary numbers, then simply these would not be they would not be real solutions. So therefore, you would only have one real solution, which is x equal to 2. But that all depends on your professor. So thank you for visiting the NJIT website. If you need any further assistance, please stop by the Center for Academic and Professional Enrichment, or the CAPE, located in Kupfrian Hall, room 200. Good luck in your studies.